In this topic, we'll be implementing UI and polishing our game. So in my level, I've got the server and 2 clients, and you can notice that each player has a HUD that shows a widget indicating health, mana, and stamina using a progress bar. And you can notice that they're actually taking damage. The loss of that health is being indicated in the widget of their HUD as well as the widget over their head. And even the consumption of ability costs are being seen. And for this minion actor that is actually blocking, if I attack this minion actor, you will notice the damage taken to its stamina in its stamina progress bar. Now let me adjust my camera so you can actually see, and you can actually notice that its stamina is being reduced. Although I think yellow was not a good color choice to indicate stamina. And so, even if I sprint, you can see the stamina consumption indicated in the stamina progress bar of my HUD's widget. And among these volume of effect actors, let me run into this sword actor and you can see the instant effect damage taken. You can also notice the periodic damages I have taken to my health under these periodic effects, and then consume this tango actor and you can see the instant heal effect that was again indicated in my health progress bar. Beyond the UI, the game has also been polished, and there is also a reticle in the middle of the screen, and we will be implementing such robust code for our UI. We'll be doing the following steps in this topic. In the first step, we'll be creating widgets for these attributes. In my base folder, I have created a UI folder. Within this UI folder, I have a few widget blueprint classes. And I also have a HUD class. You may right-click on an empty space, choose Blueprint class, and search for User Widget, and click on Select to create a Widget Blueprint class. I shall name this Attributes, and let me open this Attributes widget. I'm now presented a different editor interface for this widget. Basically, I'm in a particular designer graph, selected using this designer tab. I have a graph here in the middle, beside which I also have a palette panel. This palette panel contains many UI elements organized within their categories. And below this palette panel, you have a hierarchy panel, under which you're going to be seeing the different UI hierarchies of this attributes widget. So, the first thing you want to do in a widget class is to search for canvas, find canvas panel, and drag this canvas panel down to the attributes in this hierarchy panel. So technically, your UI elements are indicated in a hierarchy for this attribute. You can notice that I'm able to resize this canvas panel based on certain aspect ratios of screens. I prefer to keep it in the lowest ratio, and so this canvas panel can act like a container for many different UI elements. Like maybe an HTML page. Search for progress bar and drag that progress bar down to the hierarchy panel and over the canvas panel to make it the child of this canvas panel. You can notice that you have a progress bar on your canvas panel. So if this canvas panel is supposed to stretch out to a particular screen resolution, then you can have any UI element placed on any part of the area of the canvas panel. Like maybe if you want your attribute widgets in the bottom left, in the bottom center, or maybe even the top left. But since I'm not going to be using this widget for a screen and rather be displayed above a character, I shall place this UI element in the center. Now, for any UI element, you have a property known as anchors. This anchors property allows you to set the alignment of one or more UI elements within its parent UI container. So I shall anchor this progress bar in the complete center, and so you can see this flower-like icon being placed in the center. So technically, I am anchoring this progress bar in the complete center of its parent canvas panel container. I shall change this progress bar's size along the x-axis to be about 600 and the size along the y-axis to be about 20, so that this progress bar can appear quite elongated. And also, I shall reset the positions of x and y So now you can see the top left corner of this progress bar being aligned to the origin of this anchor. So now you can change the value of the position X to something negative to move this UI element towards the left. I shall use a value of half the size of X, that is half the length, so the value of -300, and I think I'll use a value of 90 for the position Y, so that I can have other UI elements below this and close to the center. Under the appearance category, find the fill color and opacity property. This is where you can set the color of this progress bar, and if this is going to be my health progress bar, I shall set its fill color to be about pure red. Under the progress category, find the percent property. So technically, this percent is nothing but a float number that can be used to set the fill percent of this progress bar. This value ranges from 0 to 1. So let me set the percentage to be about 90%, that is 0.9. And now I shall rename this progress bar. I'll call this health bar. And now let me duplicate this health bar UI element. I shall rename it to stamina bar. And so for my stamina bar, I wish to use a value of pure green. I shall set the percent to be 70% or 0.7 and position it at -300, -60 from the center origin. Similarly, I shall duplicate the stamina bar and call it the mana bar. For the mana bar, I shall use the color pure blue, where the reds and greens are 0. I shall change the percent to be about 0.5. I shall position it at -300 and -30. And so now you have created your widget for these attributes. Notice how resizing this container canvas panel is also resizing the components, or rather the UI elements, within this container. So technically in each progress bar, most of these properties values, such as percent, can be bound to a certain function, and the return value of that function is what is used as a value of this property. This function is called every periodic tick to update the percentage of this progress bar. I shall click on bind and then create binding option, and now you'll notice that I'm presented a blueprint function and the editor looks quite different. I'm basically in the same class, but I'm just in the graph tab where I have an event graph, and the function getHealthBarPercent has been created for me. You can also rename this method, such as maybe test getHealthPercentage, and you can notice that it's pretty much like the interface for any blueprint class of an actor. For this example, I shall only return a value of 0.3. And so now, in the designer graph, for the health bar property, you now have the method testGetHealthPercentage bound to the percent property. And now it's time to grant this widget to our hero character. So let me open up the blueprint hero class in my pawn directory. In its viewport, in the components panel, click on the add button and search for widget. This will add a widget scene component. I shall just rename this to attribute widget. So now you can notice in the viewport that a new attribute widget scene component exists with its own transform for this character. Scroll down to the user interface category and search for widget class. So widget class is where you specify the class of your blueprint widget which you want to render for this character. So I shall choose the attributes blueprint widget, and now you can notice that my attributes widget has been rendered on this character. It looks too big, so you can just modify the scale of this scene component's transform, and I shall set a value of maybe 0.3 or perhaps 0.2, making sure to use the lock button on the scale. That maintains the same ratio. And now I shall drag this widget component above the character's head. Scroll down back to the user interface category and notice that there is a space property, and the tooltip message says that this property determines the coordinate space in which to render the widget. And you got two options. One is world, that is, the widget is rendered in the world just like a mesh, and screen, where the widget is actually rendered on your screen and independent of the world and your location from this widget, which we will soon see. Let me set the value of world and now compile, And when I hit play, you'll notice that in my level, that widget component is still not seen. But notice my shadow. You can actually see that widget component existing. So it's only when I rotate to a particular angle, at which point you can see the widget of other actors and the other actors can see yours. So technically, this widget has been rendered in the world space like a static mesh, and it being a 2D element in the world, it is only being rendered in the front of its parent actor. Notice how, despite setting a value of 90% in the widget's blueprint, you can see that it has a value of 30%. And so that bound function was able to return the value of 0.3, which is being used by the health bar every periodic tick. So this is how the world value for scene works, where you can only see it at some angles and not everywhere. And now, let me set the value to screen and play my level again, and you'll notice that these widgets are quite big. And in fact, they appear to be pasted on my screen. It doesn't seem to be having any world rotation or a world transform, no matter how far I move away from the location of another widget. Even at that large distance, the widget will be of the same size on the screen. For the actor's widget component, let me change the space to world, and let me perform a small operation in the event tick of this actor. Basically, I'm getting this attribute widget component object and setting its world rotation based off look at rotation between the actor's location and the actor's camera's location. The look at rotation is calculated between this actor that owns this widget component and the player character's camera's world location. And this operation will happen every periodic tick. And so to summarize, this widget component is rotating based off of an angle between this actor and the player character's camera location. And now, when I play my level, you'll notice that in no matter which direction I turn, this widget component is also rotating appropriately on all machines. If you wish to, you can also dynamically change the widget scale property for the screen value based on the player's location from this character. In the second step, we'll be creating properties and methods of this attributes widget. So in my project's C++ classes directory, in the project folder's public folder, I have created a new UI folder. In this folder, you'll notice I have many Widget C++ classes and one base HUD C++ class. So we will be creating a base C++ class for widgets that will be the parent of all widgets we will use for this project. So in the Tools menu, choose New C++ class option, and in the All Classes section, search for User Widget. Click on Next and name your user widget. You can use the same name as I did, that is base_widget in capitals. Type your new folder name after the project name in the path, and make sure to choose public for the class type, so that in the public directory you will have your header file and in the private directory you will have your C++ file. And then click on Create Class, which will create this class and compile your C++ code. Although this class already exists in my project and I shall not create this class. So this is what your base widget class will look like, and this will be the parent of all widgets that we'll be using in our project. In your editor, in the C++ UI folder, right-click on the base widget C++ class and click on Create C++ class derived from base widget. And so the same box will open up to name your new C++ class. In the same folder, you can name this widget base attributes as I did, in either snake case or camel case. So check to see if your public directory will contain your header file and your private directory will contain your C++ file, and then click on Create Class. Since this class already exists in my project, I shall not be creating another C++ class. So this is what your widget base attributes C++ class will look like, that inherits from the uBaseWidget class. And in this class, we'll be creating the float values of attributes and the methods that can be bound to the progress bar's percentage. So I will create a properties section in which, under the protected access specifier, I will declare the float property health. This property can be blueprint read-only and visible anywhere in the Unreal Engine editor. I will also declare the max health float property and use the same macro to make this property visible anywhere and blueprint read only. Similarly, I shall define the corresponding properties of stamina and mana. In the method subsection under the protected access specifier, I shall declare a method setHealth%, which returns a simple float value. I shall make this function blueprint pure, so now I have exposed this method whenever I need it in the blueprints. Similarly, I will declare the corresponding methods for stamina and mana, and these are the methods that will be bound to their corresponding progress bars percentage value. So in Visual Studio Code, you can right-click on this method's declaration and click on Create Definition or Declaration option. In the C++ file, in this method's definition, I shall just return a float value that will be health divided by max health. But there can be a situation where max health would be 0 and resulting in a divide by 0 condition. This will throw an error and could potentially crash your game. So I shall handle that error using a simple if statement. In this if statement, I shall validate if this max health is equal to 0, and if it is true, I shall just return the float number 0. But I usually like to implement such return values between two values using a ternary operator. So I shall just erase all of this code, and in the return statement, in its parameter, where in the logical expression, I will validate if the max health equals 0. If that is true, I shall return 0, which is the first value written following the question mark, whereas the false value is the second value written after the colon symbol. So these ternary operators are just shorthand notations of a simple if-else statement, so getting used to such ternary operators can be really helpful. In the similar manner, I shall define my setStamina% method and the setMana% method, where using the same ternary operator, I'm returning the stamina % and the mana %. For this example, I shall use a value of 70 and 100 for my health and max health values, so that it could result in a 70%. Similarly, for the stamina and mana, I shall set them to a resultant 80% and 90%. And now, build and compile your code and run your editor in debug mode. And you can notice that in my project, for this game mode, I had always been using the HUD class blueprint base HUD. So for this demonstration, I shall remove that HUD class by setting it to none. So now let's create a child blueprint class of the widget base attributes. So if you right-click on this widget base attributes C++ class and attempt to create a child blueprint class, in my blueprint contents base directories UI folder, and this blueprint class will open up. You will notice my newly set values for health, mana, and stamina because it is after all the child of the widget base attributes C++ class. But you may also notice that this will create a standard blueprint class with only the event graph and not the designer graph. So don't create child blueprint classes of user widgets from C++ classes directly. This will create a standard blueprint class and not your designer blueprint class as you saw in the previous step. So I shall delete this class. You will have to create that same user widget blueprint class from your blueprints directory. So right-click on an empty space and choose the blueprint class. Search for widget base attributes and choose your widget base attributes C++ class. You will notice that I already have a blueprint widget base attributes blueprint class. But for this demonstration, I shall create a new blueprint class. For this widget base attributes, I shall call this class base attributes. And now you'll notice that you're presented the designer graph. Search for the canvas panel and add this canvas panel to this widget. I shall resize this to the 640 resolution. Search for the progress bar and add this progress bar into the canvas panel. These are the same steps I'm following as in the last step to create my health, stamina, and mana progress bars. For simplicity, for this health bar, I'll choose the color of white for its fill color and opacity. And in the percentage property, in the bind option, you can now notice several properties and functions that you had defined in C++. So I shall choose the setHealth% method and rename this to health bar. Similarly, I shall duplicate this progress bar and call this the stamina bar. For the fill color and opacity, I shall just use a darker shade. Now in the percentage property, I can bind the method setStamina%. And similarly, I shall duplicate the stamina bar and create the mana bar with its fill color being completely black. And now for the percentage property, I shall bind it to the setMana% method. So it's the same steps that I repeated as I did in the previous step. I just used this color scheme to show that we are operating with a different user widget altogether. Maybe you could use this color scheme in your game if you wish to have that monochrome color scheme for the health, stamina, and mana. And now it's time to assign this widget to our hero class. And now in my hero blueprint class, in the widget component, down in the widget class, I shall use the newly created base attributes widget class. So at this point, you can just replace that widget class. It's as simple as that. Let me compile the class and play the level. The whites and grays are absolutely not visible. So I guess in my base attributes widget class, I'll just change the color of health bar to somewhere around here and make it slightly darker. So it's like a dark magenta. The stamina bar, I shall make it somewhat greenish yellow. And finally for the mana bar, I shall use a lighter shade of blue. And so these are the colors I'll be using for these progress bars. And so now in my level, you can notice that all these players have their progress bars. And let me run closer to the camera of the server. And you can notice that the health, stamina, and mana are at 70%, 80%, and 90%, as set in our C++ class. And now it's time to bind the event listeners for the attribute changes. That is technically, the UI for base attribute widgets will be implemented using event listeners. The attribute changes will be broadcasted and listened to in the user widget classes. This is more efficient than digging deep into the system for values, like getting the health, stamina, or mana values during runtime, since this will involve having reference of actors' ASCs, attribute sets, and so much more during each periodic tick. So event listeners are great for such instant value changes. So this step will require implementing attribute change delegates, and this will be done in our widget base attributes class. In your header file, first forward declare the struct f_on_attribute change data and declare a method bind event listeners to delegates. In the widget base attributes C++ class, include the header files, ability system blueprint library, and your base attribute set. In the definition of your bind event listeners to delegates method, we'll attempt to get the ASC using the ability system blueprint libraries get ability system component method. Since this requires an actor for its argument, we need to know who is the owner actor of this widget base attributes. So in the header file, we'll declare the owner actor object pointer of the type actor, and we shall pass in that owner actor to this get ability system components argument. So now our concern is to assign the object owner actor to this widget, which we will do shortly. Let's validate this ASC, that is, if it is not a valid pointer. So we shall return if the ASC is a null PTR. I shall now attempt to get the base attribute set of this ASC. I shall declare a local variable and make it constant. We can use the ASC's getAttributeSet method and pass in the base attribute set's static class. So we see a red squiggle which states that the constant attribute set object pointer cannot be assigned to a variable of the type const uBaseAttributeSet object pointer. This can be easily resolved by casting, and to the cast's template parameter, I'll pass the uBaseAttributeSet class, just like how we did to get the movement speed attribute from the battle attribute set, as in topic 4.1. So we can assign a value to our health property of this widget base attributes class by calling the base attribute set's getHealth method. Similarly, I'll get the value of the max health attribute of the base attribute set object and assign it to the max health property of this class. I shall do the same for the corresponding stamina attributes and for the mana properties. This is really very costly because it involves getting the ASC, the attribute set object, and casting it only to get the attribute values. So in this manner, we can actually instantiate values of this class, because this method is actually part of the initializing process of this widget. You can do the same for the base character movement component, where we're getting the movement speed every periodic tick. And now it's time to bind certain event delegates with event listeners. We can get that event delegate using the ASC's getGameplayAttributeValueChange delegate. This returns that event delegate on GameplayAttributeValueChange and takes in the parameter of the type fGameplayAttribute. So we can pass in any attribute such as our health attribute using its attribute accessor method, and we can bind this returning event delegate using the addUObject method. This method has its own signature, that is, its own return type and parameter. So how do we know what is that method and what is the method signature? For that, we'll have to explore what is this onGameplayAttributeValueChange delegate. So right-click on the getGameplayAttributeValueChange delegate method, and this takes you to the header file of the ability system component itself. We can see a lot of helpful event delegates for the various events handled by the ASC in GAS. You can see a delegate onGameplayEffectApplied, which is in fact of two types, to self and to target. And you can also see certain delegates for abilities, when a gameplay ability ended, or a callback when the ability fails. So we are interested in the onGameplayAttributeValueChange. So if you hover over that, your IDE will show you its declaration. You may alternatively go to the definition or the declaration of this change delegate. So this multicast delegate operates on a function of this signature, the return value being void, and the parameter being const onAttributeChangeData passed by reference. So that will be the method signature to be used for that delegate for an event listener method. So copy that method signature and declare a method of that signature in your base attributes widget header file. So this is the syntax Unreal Engine follows while binding any event delegate. It requires you to pass that method address, and that is done by passing the class name, the scope resolution operator, that is the double colon, and the method name. And this is passed by reference using the ampersand symbol. Similarly, let's declare the event handler for the max health change, and this will be called whenever the max health changes, and likewise for stamina and mana. So how are we going to handle this attribute change? We have a helpful payload that contains data on the attribute changes. We'll assign our health property with the data's new value property, which is actually the new attribute value during this attribute change. So optionally, we can set the health percentage. Although the set health percent is being called every periodic tick, it is still a wise decision to set the health percentage upon receiving the new health value. Similarly, I shall do that in the max health change event handler method definition, where I will set the max health with the data's new value and again set the health percentage. And similarly for stamina and mana. So that's really all there is to it, getting a delegate and binding a delegate. And this is part of the GAS boilerplate. So the second half of the step involves initializing this widget. So in a widget base attributes class, declare the initializeWidget method with a single parameter, an actor object pointer. We'll assign the owner actor of this class with the incoming owner and call the bind event listeners to delegates method. So it's now time to implement this widget base attributes for our base character, which will apply to the hero and the minion as well. Firstly, I'll be including the header file components widget component. This is the header file for UI, and in the complete bottom of this base character header file, I'll create a UI section and a method subsection. I will declare an initializeWidgets method and make it blueprint callable. I'll also create a simple boolean flag property that will indicate if these widgets were initialized. And in the definition of the initializeWidgets, I shall first validate if the widgets were even initialized. If true, that is if the widgets were indeed initialized, I shall return. Inside an if block, I shall create a local variable of the uWidgetComponent object pointer and use the getComponentByClass method. So with this method, I wish to get that widget component that we set in the blueprints. And if it's declared in this if statement, the scope of this local variable is only within this if block. As for the getComponentByClass method, you can also use the template method, but for simplicity, I'll use its conventional method. And for the argument, I shall pass this uWidgetComponent static class. You will notice there's a red squiggle which states that the return value of the actor component object pointer cannot be used to initialize a variable of the type uWidgetComponent object pointer. And so we can just cast this actor component object to the uWidgetComponent class. And now from this widget component, it is time to get the widget base attributes that it has rendered over the actor's head. So I shall create a local variable of the type widget base attributes object pointer and call the widget components method getUserWidgetObject, and this shall too be casted to the uWidgetBaseAttributes class. So let's return if we could not get the base attributes widget object, and now it's time to initialize our newly created widget object for the base attributes. we can call this object's initializeWidget method, which we recently created, and pass this object for the owner parameter. And at this point, you have successfully initialized the base attributes widget, so we can just set this widget's initialized Boolean property to true. So this may have seemed like a very complicated process, but it is not really. So whenever you encounter such complexities, you can add a debugger to your code, and so you can analyze the code execution. So in Visual Studio Code, I'll just click on this line number 161 in this gutter, that's what it's called, to add a breakpoint. So whenever the program reaches this part of the code, I can analyze the flow of my code. So now you can build and compile your code. I've run my editor in the debugger mode, and let's work on this newly created base attributes widget blueprint class. Oh, and by the way, if your code doesn't compile, and if your forward declaration of the structure on attribute change data doesn't work, you may just copy paste these header files from the C++ class and paste them into your header file. Now my build was a success, and it's now time to call the initializeWidgets method. I shall invoke that in the Blueprint Heroes begin play. So in the event begin play, after calling the parent begin play, and do make sure to call that, or else the parent's begin play will never work, we'll perform a sequence of operations where I'll add a delay of 2 seconds and then call the initializeWidget method. I just like using the sequence node in blueprints. It makes the blueprint scripting similar to programming in code. So this delay is applied just so everything is loaded. That is, the attributes are added, effects are applied, etc. particularly in a multiplayer environment. And we shall also do the same in our minion class, where after its begin play and the parent begin play, I had used a delay node and performed the block ability, and in the second sequence of operation, I applied a delay of 2 seconds and called the initializeWidgets method. And make sure to have a widget base attributes component as a scene component, that is the scene component of your actor. And for this widget class, I shall choose the base attributes widget. Now I do have a debugger in Visual Studio Code, and the code might run into that, so I shall play this game in the single player standalone. So you may have noticed how the level loaded, and after about 2 seconds, the execution paused at the debugger. So now it's time to check if our initializeWidget method of this base attribute widget object will be called. So if I press this step into of the debugger controls, you'll notice that my execution has arrived in the widget base attributes class and inside the initializeWidget method. So the execution successfully brought me to the widget base attribute C++ class, and you can hover over this owner parameter and notice that this is the blueprint hero. So for the blueprint hero, this widget base attribute has been assigned and is ready to have its event listeners bound. So I'm successfully getting the ASC as well as the base attribute set object pointers. So I will just step over the next few lines, and in the debug inspector, you'll notice that for this object, I have the float properties of health, stamina, max stamina, mana, and max mana, the same values as that of the base attribute set. So click on continue to proceed with the execution, and you'll notice that the debugger stops again, this time for the blueprint minion character. And stepping over each of these lines, you will notice that this widget's float properties now match the same attribute values. And let me continue my debugger execution. Now let me open up my level again, and you'll notice that my widget has full progress bars for the health, stamina, and mana. And if I run into this ward actor, you can notice the damage taken to my health, and also the health regeneration that is happening with the heal infinite effect. Performing my triple jump has consumed the stamina cost, and you can also see the depletion of the stamina bar. Running into this fire effect actor is also showing the periodic damage taken, and the periodic intervals are executing accurately. Collecting this tango actor has given me bonus health, and for this minion actor that is currently blocking, if I keep attacking this character, you'll notice that its stamina is being damaged. So now our newly created widget is successfully working. So we did implement that 2-second delay so that in a multiplayer environment, all the players can load, their levels can load, attribute sets can be granted, and effects can be applied. Almost all games have such kind of a delay in a multiplayer setting, like Dota Strategy Time. So it is useful to have such kind of a delay after initializing gas and initializing other systems that rely on gas. And so let me play my level with 3 players, but this time not using a server and playing with 3 clients. Okay, wow, the execution hit my debugger, and let me just disable that and continue the execution. So in my level, I'm able to consume stamina, and that's also visible to other players. I shall bring this character close to this client 3's camera so you can see better. Let me bring this client 2 to the client 3 and let me position him better. And if I attack this player, you can notice the loss of health due to the damage taken. So yes, this is also working in multiplayer.